Okay, in this video, I'm going to introduce what is the meaning of integration. Alright, so when you differentiate a function, let's say when you differentiate a function, you differentiate a function and you're getting another function, right? Usually this function is the derivative of this function, right? Gx is the derivative of fx, right? As you know when you're learning differentiation, right? So as you differentiate fx, you are getting gx, and gx is a derivative of fx, or sometimes we label this as f prime x, right? It's a derivative of fx. So what happened when you integrate, right? What happened when you integrate? So what we said as antiderivative means the reverse process. So when we integrate f prime x, or we said we integrate gx. So this is the process. So it's a reverse process. When you differentiate fx, you're getting gx. So gx is your derivative. So once you integrate f prime x, integrate gx, you will get back the function, right? Differentiate, you're getting this. So as you reverse the process, you will get, as you integrate gx, you are getting fx. You are getting fx. And fx, we name this to be an antiderivative, right? Antiderivative. So means that gx and f prime x is the derivative of a function. So as you derive this one, you're getting this. This is a derivative of fx. So but once you integrate this one, you get back fx. And fx, we name it as antiderivative. There is a name for this. Fx is antiderivative. Or we said this to be another synonym, it will be integral. This will be the integral. So means the product will be, we name as integral. So as these two, fx or gx, so we name this to be a integrand. Alright? Integrand. Alright? Integrand or derivative of fx. So once you integrate, you're getting antiderivative. So there is a name which is called antiderivative or integral, and this is the integrand. So the process, this process of antiderivative, we integrate the integrand with respect to x, and we get back the antiderivative or integral is named as integration. Alright? Integration. So the process of fx, once you derive, you differentiate fx, you're getting gx. This is called differentiation. So as you reverse back from gx, which is a derivative of fx, become antiderivative, this is called integration, right? The reverse process is called integration. Alright, hope you understand the meanings of differentiation and integration. Alright, so as you know how to differentiate, there must be a way of integrate. So there are many complex formula and techniques in coming back and going forwards, right? So in this level, we're going to study about a single integral, right? In the same video also, I'm going to introduce you what is the meaning of integration, right? Let's look at the example. So let's look at this example here. So the meaning of integration here. So let's say you have a function of 2x to the power of 2, right? 2 to the power of 2. So when you differentiate, right? When you differentiate this thing, means you differentiate the fx, right? You differentiate the fx, so you will get, means you are actually differentiating 2x squared, right? 2x squared. So as you differentiate, you're getting 4x, right? You're getting 4x. So once you integrate, so means that this is the derivative, right? Derivative of fx, right? Derivative of fx. So means that this is the derivative of 2x squared. So now I going to, once when I differentiate, I'm getting 4x. Now I want to integrate, right? Integrate this. So when I integrate this, means that it's a reverse process. which I will get back the antiderivative, right? This is my antiderivative, the integral for this, right? The solution. So, which usually we add a C, right? For indefinite integral, right? For indefinite integral that you learn during your Form 5 STPM, right? Where they introduce what is meant by indefinite integral. So then you know that your teacher teaching you that there is a plus C here. Do you really go and read a textbook, your textbook and some reference book? So they have tell you that actually why there is a plus C, right? Okay, let's look at the reason here. Because, okay, let's look at several examples. As I know that differentiate 2x squared, I will getting 4x, right? I will getting 4x. So what happened when I differentiate 2x squared plus with 1, right? This one is different for this, from this one because there is a constant, right? There is a constant here, 1, okay? So as you differentiate this, you will differentiate, you're getting 4x. And the differentiate constant, you're getting 0, right? You are still getting 4x, right? So, for example, you differentiate 2x squared, negative 10. For example, negative 10. Yeah, this is different from this and this is also different from this, right? But when you differentiate, they have the same product, alright? They have the same derivative, okay? So, you differentiate, you're getting 4x, right? No matter what you do, as long as there is a 2x squared and a constant, alright? And a constant, for any constant, okay? It can be any constant, let's say pi, right? So, you differentiate, you're getting 4x, right? There are so many possibilities, right? You differentiate this, you're getting all the first derivative. So means when you go back, when you integrate 4x dx, so this is an indefinite integral, right? You're not sure where is the region, right? Where is the limits here? So means that when you integrate 4x, then when you go back, there are many types of function, many possibility. So then you have antiderivative 2x squared plus with C. The C here is to tell you that there is this one is like plus 0, is a constant, right? 1 or maybe negative 10. Maybe there is a constant after you integrate. So this is the way when you do indefinite integral, alright? So this is all the antiderivative of 4x, alright?